Quantum computing, explaining qubits and the future of computation. Imagine a computer that can solve problems too complex for even the most powerful supercomputers today. That future is closer than you think, thanks to the mind-bending world of quantum computing. Get ready to dive into the quantum realm and explore how it's poised to revolutionize everything. Quantum computing represents a revolutionary departure from the way classical computers process information. Instead of bits, which are either 0 or 1, quantum computers use qubits. This allows them to tackle problems currently considered intractable. Classical computers are limited by their binary nature. Quantum computers, however, leverage the principles of quantum mechanics. This opens up possibilities for solving incredibly complex calculations. The potential of quantum computing is vast. It promises to reshape industries and solve some of humanity's biggest challenges. A qubit, short for quantum bit, is the fundamental unit of information in a quantum computer. Unlike a classical bit, which can only be 0 or 1, a qubit can exist in a state of superposition. This is where the magic begins. Superposition means a qubit can be both 0 and 1 simultaneously. Think of it like a coin spinning in the air. It's neither heads nor tails until it lands. This ability to exist in multiple states at once dramatically increases computational power. It allows quantum computers to explore many possibilities simultaneously. Another key concept is entanglement. This is where two or more qubits become interconnected. The state of one entangled qubit is instantly linked to the state of the other, regardless of the distance separating them. It's like they're communicating instantaneously. Entanglement enables incredibly complex calculations and parallel processing. This is something classical computers simply can't achieve. Quantum computing has the potential to revolutionize numerous fields. From drug discovery to financial modeling, the possibilities are truly transformative. Let's explore some key applications. In drug discovery, quantum computers can simulate molecular interactions with unprecedented accuracy. This allows for faster and more efficient drug development. Imagine designing new medicines and therapies tailored to individual patients. Quantum computing could make this a reality. In materials science, quantum computers can design novel materials with specific properties. This could lead to breakthroughs in energy storage. Think of more efficient batteries and superconductors. Quantum computing could unlock these advancements. Financial modeling is another area ripe for quantum disruption. Quantum algorithms can optimize complex financial models. This leads to improved risk assessment and more effective portfolio management. Quantum computing could revolutionize the financial industry. Cryptography faces both a challenge and an opportunity with quantum computing. Quantum computers have the potential to break existing encryption methods. However, this also drives the development of quantum-resistant encryption. This will ensure secure communication in the quantum age. Despite its immense potential, quantum computing faces significant challenges. Building and maintaining stable qubits is incredibly difficult. Qubits are extremely sensitive to environmental noise. This includes vibration, electromagnetic radiation, and temperature fluctuations. To function properly, qubits often require extremely low temperatures. We're talking colder than outer space. They also need to be isolated from external disturbances. This makes building and operating quantum computers a complex engineering feat. The development of quantum algorithms and software is another hurdle. We need new programming languages and techniques to harness the power of qubits. Despite the challenges, researchers are making significant progress. They are improving qubit stability and increasing their power. New quantum algorithms and programming languages are being developed. This will make it easier to program and utilize quantum computers. We can expect quantum computers to tackle increasingly complex problems in the coming years. This will impact various industries and aspects of our lives. The future of quantum computing is bright. It promises to unlock solutions to some of humanity's greatest challenges. Quantum computing is not just a technological advancement, it's a paradigm shift. It's a new way of thinking about computation and problem solving. As the technology matures, we can expect to see even more groundbreaking applications emerge. The quantum revolution is on the horizon, and it's poised to reshape our world in profound ways. Ready to learn more about this exciting field? Dive deeper into the world of quantum mechanics, explore the latest research, and consider how you can be a part of this technological revolution. Subscribe to our channel for more informative videos. Leave a comment below with your thoughts, and share this video with anyone who's curious about the future of computing. Let's explore the quantum realm together.